with the part of the which is dimensional analysis, and all conveying information using conversion factors. So, what are examples of some conversion factors? Meter centers, and one is also to point. So, these are conversion factors. And something else, the only way you can if you apply a lot of problem practice and getting conversion factors and getting used to start where you end. So I'm gonna first problem provide she has solved the problem start ahead and tips we're solving the problem. My problems how many years are in 2.26 gigaseconds. So this is a tip to keep in mind whenever you're solving dimensional problems. Like start value. Where do you want it? What do you get from? So our starting value will only number the only numerical value we have to have is 2.2. Starting with the years that are in 2.6 seconds. So the ending is to be okay. So the start and end gives you a very neat idea of where you are, where you get at. So that's the main point that you guys focus to that is helpful. Another thing that we should consider when we're talking about dimensional analysis is that you always want to write as many conversion factors as you can. The conversion factors are very significant when we're trying to get from here to here, from point A to from point B. So let's just jot down a few conversion factors that we may potentially use in this problem. Okay, so, well, we know that 1 second is equal to 10 to the negative 9th gigaseconds. We know that 1 minute is equal to 60 seconds. We also know that 1 hour is equal to 60 minutes. We know that 1 day is equal to 24 hours. And we know that 1 year is equal to 365 days. So these are just some conversion factors that we might end up using in order for us to solve this problem. Okay, so based on our start and our end, we said that we are going to start off with 2.6 gigaseconds. So now, gigaseconds. Which one of these conversion factors can we actually use that's going to help us, cross out the gigaseconds? Well, the only one I see with gigaseconds would be this conversion factor. So we know that 1 second is equal to 10 to the negative 9th gigaseconds. One thing to realize when you're doing dimensional analysis is that the top and the bottom numbers, the numerator and the denominator of the numbers, they need to have the same unit so that they can cross out. So gigaseconds are going to cross out. So now we are trying to cross out the seconds. So now we're going to look at any conversion factor that contains seconds. Let's look at this one. So I'm done with this one. Let's cross this one out. So then we know that 1 minute is equal to 60 seconds. So I'm going to say 60 seconds is equal to 1 minute. seconds and seconds, so these are going to cross out. So now I'm going to try to cross out the minutes. You know that we can use this one. So 60 minutes is equal to 1 hour. So I'm done with this one. I'm done with this one. We're going to try and get rid of the hours. So let's use our other conversion factors. We said 24 hours is equal to 1 day. So we're done with this one. And our last conversion factor, which is going to get us to our end point, which is years, should be 1 year is equal to 365 days. So we know that everything is starting to cross out. And whatever you're ending with, whatever you want to get as an answer should always be on the top. Or in other words, whenever you're solving one of these problems, everything else should cancel out and what you want shouldn't cancel out. So once we solve this, we are going to get 82 years. So looking back at our problem, how many years are in 2.6 gigaseconds? 82 years are in 2.6 gigaseconds. Okay, so now we're going to go on with number 2. Number 2 says that there are 265 special blueberries in a bucket. Each blueberry weighs 0.80 grams. These blueberries are special in the sense that they are entirely composed of copper. How many moles of blueberries are present in the bucket? Okay, so we're going to start off with our start and end procedure. So we're starting off with 265 blueberries. I'm going to shorten it to BB, which stands for blueberries, and we want to end with the moles of blueberries. So now let's talk about some conversion factors. So we know that there's 265 blueberries. We know that one blueberry weighs 0.80 grams. We also know, we're also given some significant information that the blueberries are composed entirely of copper. So that means that 1 gram of a blueberry is equal to 1 gram of copper. So we know that 1 gram of blueberries is equal to 1 gram of copper because the problem tells us that they are equivalent to each other. So because we're trying to get moles of blueberries, we also know that we can kind of convert grams to moles by using molar mass. So we also know that 1 mole of copper, based on the periodic table, is equal to 63.546 grams of copper. So using these conversion factors, we're trying to see how many moles of blueberries there are. So we're going to start off with 265 blueberries. We're going to use this conversion factor because it's going to cancel off. Then we're going to try to cancel off the blueberries. We know that 1 gram of blueberries is equal to 1 gram of copper. And we know that 63.546 grams of copper is equal to 1 mole of copper. And by solving this, we are going to get 3.3 moles of copper. And I'm just going to put this in my calculator just to recheck. 265 times 0.8 divided by 63.546. Yes, 3.33. And we're going to multiply. The answer is going to be to 2 significant figures because of this number right here. And we know that because 1 gram of blueberry is equal to 1 gram of copper, and the blueberries are pretty much copper, we can say that there are 3.3 moles of blueberries in the bucket.